Let us discuss enthalpy of hydration. So enthalpy of hydration we are taking. So for enthalpy of hydration, let us take example anhydrous copper sulfate. Anhydrous copper sulfate. This anhydrous in the sense it is not having water molecules. This anhydrous copper sulfate takes required amount of water to give hydrated copper sulfate. To give hydrated copper sulfate. For this enthalpy of reaction, enthalpy of this reaction is called minus 78.87 kilojoule per mole. So this process is called hydration. This copper sulfate takes required quantity of water molecules to form hydrated salt. It is called hydrated salt. This hydrated salt, for the formation of hydrated salt, what is the enthalpy change means minus 78.87. That means enthalpy of hydration. Enthalpy of hydration means 1 mole of anhydrous salt we have to take, required quantity of water we have to add, then we have to get 1 mole of hydrated salt we have to get. For this, what is the enthalpy change? What is the net amount of heat change? That is called enthalpy of hydration. Okay. Next, we will see about enthalpy of neutralization. Enthalpy of neutralization we will see. So, what is neutralization? Acid reacting with base to give salt and water, that is called neutralization. So neutralization means acid reacts with base to give salt and water, that is called neutralization, we can say. Okay. Now how to define neutralization? How to define neutralization we'll see. Now we have to take a 1 gram equivalent of acid. 1 gram equivalent of acid we have to take. This 1 gram equivalent of acid should react with 1 gram equivalent of base. 1 gram equivalent of base to give salt and water. To give salt and water. For this process, what is the enthalpy change? What is the heat energy change? What is the heat energy involved for this process? That is called enthalpy of neutralization. Okay. So enthalpy of neutralization means how much acid should react? 1 gram equivalent of acid should react. How much base should react? 1 gram equivalent of base should react to give what and what? Salt and water. For this process, what is the net amount of heat involved? What is the net amount of heat involved? That is called enthalpy of neutralization. So this process is called, in this process, what is the amount of heat involved? That is called enthalpy of neutralization, we can say. Sir. Now we will take an example. Acid is strong acid, base also strong base will take. Acid example HCl will take, HCl aqueous. Base example sodium hydroxide, we will dissolve sodium hydroxide in water. Then on mixing HCl and NaOH, we are getting a NaCl and water. Okay. For this process, for this reaction, what is the energy involved? What is the heat involved in this process? That is called enthalpy of reaction. Enthalpy of reaction is equal to minus 57.32 kilojoule, we can say. Minus 57.32 kilojoule. That means here we are taking strong acid HCl, strong base sodium hydroxide. Both are mixed in water. Those solutions are mixed with each other. They are going for chemical reaction and they are going for acid base neutralization to give what in the sense salt and water. For this, what is the heat involved in the sense minus 57.32 kilojoule. Minus 57.32 kilojoule amount of energy is involved. Sir, okay. Now, this HCl aqueous, how much we have taken in the sense 1 mole we have taken as per this stoichiometry of equation. Here HCl is how much means 1 mole. This HCl gives 1 H plus. 1 HCl gives 1 H plus. Therefore, N factor is 1. N factor of HCl is 1. N factor is 1 means number of moles and number of gram equivalents are equal. N factor is 1 means number of moles and number of gram equivalents are equal. So 1 mole means we can say 1 gram equivalent. 1 mole and 1 gram equivalent both are same when n factor is 1. Okay. So HCl, how much we have taken for the reaction means 1 gram equivalent of HCl. Sir. Next we will see about NaOH. Stoichiometric coefficient is 1. Therefore NaOH we can say 1 mole we can say. 1 NaOH can give 1 OH minus ion. Therefore n factor is 1. N factor equal to 1. N factor is 1 means number of moles of sodium hydroxide and number of gram equivalents both are equal. Number of moles and number of gram equivalents both are equal. So 1 mole of NaOH means we can say 1 gram equivalent of NaOH. We can say 1 gram equivalent of NaOH we can say. N factor of sodium hydroxide is 1. Therefore, number of moles of NaOH and number of gram equivalents of NaOH are equal. So 1 mole of NaOH means we can say 1 gram equivalent of NaOH. Okay. So here how much HCl reacting as per stoichiometry in the sense 1 gram equivalent of HCl is reacting with how much base means 1 gram equivalent of sodium hydroxide to give what in the sense salt and water. Therefore, when 1 gram equivalent of acid reacts with 1 gram equivalent of base, while what is the heat involved, that is called what? Enthalpy of neutralization. Therefore, we can say this is called a enthalpy of neutralization between HCl and sodium hydroxide. HCl and sodium hydroxide we can say. So enthalpy of neutralization between HCl and sodium hydroxide is what? Minus. Minus means exothermic. And how much heat is liberated? 57.32 kilojoule of heat is liberated when 1 gram equivalent of HCl undergo complete reaction, complete neutralization. Like that we can say. Sir. Next, this HCl is dissolved in water. This HCl is dissolved in water. HCl dissolved in water means HCl will exist as a H plus aqueous Cl minus aqueous. HCl in solution, HCl in aqueous solution will exist in the form of H plus ions and Cl minus ions. It undergoes complete ionization because strong acid. It undergoes complete ionization. Why? Because it is strong acid we can say. HCl is strong acid. Therefore, it undergoes complete ionization. So, it exists in the form of H plus aqueous and Cl minus aqueous we can say. Okay. And NaOH in solution, NaOH is dissolved in water. So NaOH exists in the form of ions. What are the ions in the sense Na plus ions and OH minus ions? Sodium hydroxide exists in the form of Na plus ions and OH minus ions we can say. Okay. So sodium hydroxide is dissolved in water. Sodium hydroxide is a strong base. Therefore, it undergoes complete ionization and exists as what in the sense Na plus ions and OH minus ions we can say. Sorry. Sodium hydroxide, how it is existing we know. Then sodium chloride is dissolved in water. Therefore, the sodium chloride is a salt. It undergoes complete ionization. So, to what extent it undergoes ionization means if it is mentioned, we have to consider that percentage. Otherwise, we have to consider 100% ionization. So, NaCl undergoes complete ionization. Therefore, it will exist in the form of what in the sense Na plus ions and Cl minus ions. Then what is there here in the sense water? Water is a polar covalent molecule. Therefore, don't write in the form of ions, write as a molecule. Okay. So, we have written water. Next, what are the common things that we can cancel? In the left side, Na plus aqueous is there. Right side also Na plus aqueous is there. Therefore, Na plus ion is spectator ion. Therefore, we have cancelled that. Okay. Left side Cl minus aqueous is there. Right side also Cl minus aqueous is there. So, we have cancelled that. So, what is the rest in the sense? In the here H plus aqueous is the rest. Here OH minus. OH minus we can write in this form. This oxygen is having 3 lone pairs here. OH minus aqueous we have written. Then this right side what is there means water is present. Right side what is there means water is present. That means this acid H plus and base OH minus, between them what is formed, that you see, between acid H plus and base OH minus what is formed in the sense this H plus is having vacant orbital because it is having no electrons, so it is having only vacant orbital. This OH minus oxygen is contributing lone pair to this H plus and forming a bond. Therefore, when HCl is mixed with NaOH, only bond formation takes place. Bond formation occurs. Bond formation takes place. Bond formation in the sense attraction, therefore energy is liberated. So what is the amount of energy liberated in the sense 57.32 kilojoule of energy is liberated. Therefore enthalpy of neutralization is this. So this enthalpy of neutralization between HCl and sodium hydroxide can also be defined as 1 mole of H plus ions combines with 1 mole of OH minus ions to form 1 mole of water. That means 1 mole of this bond is produced. 1 mole of this bond is produced while 1 mole of this bond is produced, while what is the amount of heat released, that is called enthalpy of neutralization. Like this also we can define. Okay, so enthalpy of neutralization we can define in another manner. That is what, when 1 mole of H plus ions combines with 1 mole of OH minus ions to form 1 mole of water, that means 1 mole of this OH bond is produced, while what is the amount of heat released, that is called enthalpy of neutralization. For this enthalpy, for this process, what is the heat involved in the sense minus 57.32 kilojoule of heat is involved. Okay, when H plus combines with OH minus to form water, what is the amount of heat involved in the sense minus 57.32 kilojoule of heat is involved. Okay, why? Because this is the, when HCl is mixed with NaOH, so and so is formed, so and so is taking place, because Cl minus get cancelling, Na plus get cancelling. There is no change for Na plus and Cl minus. Only H plus and OH minus make a bond. Therefore, so and so process taking place. Therefore, this for this enthalpy is how much, means minus 57.32 kilojoule we can say. Okay, so how to define a enthalpy of neutralization of HCl and sodium hydroxide? How to define? Okay, so how to define in the sense HCl we have to take 1 gram equivalent, sodium hydroxide we have to take 1 gram equivalent. We have to make them to undergo complete reaction. While what is the amount of heat involved, that is called enthalpy of neutralization between HCl and sodium hydroxide we can say. Now, this HCl aqueous we can write in the form of H plus ions and Cl minus ions. Sodium hydroxide aqueous we can write like this. We are cancelling. So, what is the rest in the sense so and so? Therefore, enthalpy of neutralization we can define like this also. When 1 mole of H plus ions combines with 1 mole of OH minus ions to form 1 mole of water, while what is the amount of heat involved? That is called while what is the amount of heat involved? That is called enthalpy of neutralization. Enthalpy of neutralization we can say. Okay, so enthalpy of neutralization is so and so. Okay, so enthalpy of neutralization definition we got. Okay, now here we have taken HCl is, here we have taken HCl. HCl comes under strong acid. NaOH comes under strong base. Okay, all the strong acids which are strong acids we will see. Strong acids we will take, that is HCl, HBr, Hi, HClO4, H2SO4, HNO3. These are strong acids. All these strong acids undergo complete ionization in water. Complete ionization in water is possible. All the strong acids undergo complete ionization in water. So, therefore, whatever the strong acid you take in water, that will exist in the form of H plus ions and anion. Okay, and strong bases. Which are strong bases? We'll see. Strong bases in the sense alkali metal hydroxides, that is sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide. These are strong bases. All the strong bases undergo complete ionization in aqueous solution in water. They will undergo complete ionization in aqueous solution. Therefore, for strong acid and strong base, what is the definition for heat of neutralization? Means, now we will say definition for heat of neutralization in general. In general, what? Then we'll see strong acid and strong base. Okay. So now we are saying definition for heat of neutralization for in general we are saying heat of neutralization between acid and base. In general we are saying that is how, in the sense when 1 gram equivalent of acid reacts with 1 gram equivalent of base to give salt and water, while what is the amount of heat involved, that is called heat of enthalpy of neutralization. It is general definition. Even for strong acid and strong base also, this is the definition. For strong acid and strong base, enthalpy of neutralization will be defined in another way. What is that? When 1 mole of H plus ions from acid reacts with 1 mole of OH minus ions from base to give 1 mole of water, while what is the amount of heat involved? That is called enthalpy of neutralization. Okay. For strong acid and strong base, enthalpy of neutralization can be defined in this equation form. Okay, so for enthalpy of neutralization between strong acid and strong base means two definitions we said. One definition is this H plus OH minus gives water. Another definition is a 1 gram equivalent acid plus 1 gram equivalent of base. Two definitions. Okay, this definition, this 1 gram equivalent of acid, that definition is general for whatever the acid and whatever the base. This H plus ions plus OH minus ions, this definition for strong acid and strong base only. Okay, so now we have this, we said enthalpy of neutralization, we said by taking example HCl and sodium hydroxide. Sir, okay. Next, we will take some other example. We will take, now we will take sulfuric acid. We will take strong acid is what means sulfuric acid we will take. And strong base will take, that is potassium hydroxide will take. Sulfuric acid we have dissolved in water, potassium hydroxide also we have dissolved in water. What is the salt obtained now? What is the salt obtained? That is of Na2SO4. That means here potassium hydroxide we have taken, therefore we will write K2SO4 we will write. Sir, K2SO4 we have written. Then we are writing water, we are writing water is produced. Now what is the enthalpy of this reaction? Is enthalpy of this reaction equal to minus 57.32 kilojoule. Okay. Now here what this sulfuric acid, how much we have taken, in the sense half mole we have taken. What is the N factor of sulfuric acid? In the sense sulfuric acid is converting into sulfate, therefore N factor is 2. Number of moles N factor, if you multiply both you will get number of gram equivalents. Multiply this number of moles and with the N factor you are getting gram equivalents, that is how much means 1 gram equivalent of acid. 1 gram equivalent of acid. In the same way KOH, in the sense N factor is 1, therefore number of moles is equal to number of gram equivalents. Okay. So here, so that in this process, in this reaction, what is the amount of heat involved? That heat is called enthalpy of neutralization. It is called enthalpy of neutralization between what and what, in the sense between sulfuric acid and potassium hydroxide. Okay, so we have discussed enthalpy of neutralization between strong acid and strong base. Okay, now we said in the previous case we have taken HCl and sodium hydroxide. For that enthalpy of neutralization is minus 57.32. Now we have taken sulfuric acid and potassium hydroxide, for which we are saying enthalpy of neutralization is minus 57.32. So from this we can conclude that enthalpy of neutralization between any strong acid and strong base remains same. Okay, so enthalpy of neutralization between any strong acid and strong base remains same. Why? Because strong acid undergoes complete ionization in water, strong base also undergoes complete ionization in water. Therefore, okay, so next type we will take. Next type, what, in the sense strong acid and weak base we will take. We are taking strong acid versus weak base. So strong acid versus weak base we will take. Here how the enthalpy of neutralization will be there, that we will see. Now strong acid example HCl we will take, that we will dissolve in water. And weak base, what means ammonium hydroxide. Ammonium hydroxide is ammonium hydroxide aqueous solution we will take. Both we are mixing, what we are getting, in the sense ammonium chloride aqueous we are getting, ammonium chloride salt solution we are getting, then water we are getting. Okay, for this reaction, what is the heat involved? For this reaction, what is the heat involved, in the sense that is minus 51.46. Minus 51.46 kilojoule. Okay, here how much HCl means 1 mole of HCl. 1 mole of HCl. HCl N factor, you know that is 1. 1 mole of HCl means 1 gram equivalent, we can say 1 gram equivalent of HCl we can say. Ammonium hydroxide we have taken 1 mole as per stoichiometry of the reaction. 1 mole of ammonium hydroxide we have taken. Its N factor is how much, in the sense 1, because 1 ammonium hydroxide can give 1 OH minus ion, therefore N factor is 1. n factor is equal to 1, and therefore number of moles is equal to number of gram equivalents. So number of gram equivalents, how much in the sense 1 gram equivalent, 1 gram equivalent of ammonium hydroxide. Okay, so HCl is how much means 1 gram equivalent, ammonium hydroxide how much means 1 gram equivalent. They are reacting to give salt and water. Now what is the heat involved in the sense minus 51.46 kilojoule. This amount of heat is also called what in the sense enthalpy of neutralization between strong acid HCl and weak base ammonium hydroxide. Okay, this is called enthalpy of neutralization between strong acid HCl and weak base ammonium hydroxide, we can say. Okay, so now we said enthalpy of neutralization, we said. Okay, so enthalpy of neutralization between strong acid HCl and weak base ammonium hydroxide is how much, that we got an idea. Okay, now we will compare this enthalpy of neutralization with the previous case. Previous case, you see that the previous case, how much enthalpy of neutralization means minus 57.32 kilojoule. Now enthalpy of neutralization, how much in the sense minus 51.46. Minus 51.46 we are saying. So why enthalpy of neutralization is low now? Enthalpy of neutralization is getting decreased now. Strong acid and strong base means minus 57.32. Now strong acid and weak base means minus 51. That means amount of heat liberated is low now. Why amount of heat liberated is low? What is the reason? That we'll see. Now HCl is a strong acid. This strong acid in the sense it will exist in the form of ions in the solution. HCl aqueous exists in the form of ions in the solution. HCl aqueous exists in the form of ions in the solution, we can say. Okay. Why HCl undergoes complete ionization? Why HCl exists in the form of completely ions in the solution? Because it is strong acid. Sir. Now we will take ammonium hydroxide. This ammonium hydroxide also dissociating. Dissociating means split into ions. So ammonium hydroxide also split into ions. One is cation. Cation is what means ammonium ion. Anion is what in the sense OH minus ion. Anion is what in the sense OH minus. So ammonium hydroxide aqueous undergoes ionization. Ammonium hydroxide aqueous undergoes ionization. Ionizing to give what are the ions? One is ammonium ion, another one is what means hydroxide ion. So ammonium hydroxide aqueous undergoes ionization to give what in the sense ammonium ions, and then hydroxide ions, we can say. This ammonium hydroxide is a weak base. Weak base in the sense it will not undergo complete ionization. It undergoes what in the sense partial ionization. Partial ionization means it will give ammonium ions and hydroxide ions partially. Okay, so it undergoes partial ionization. Partial ionization in the sense suppose if you take 1 mole of ammonium hydroxide, after some time if you see 1 minus x moles of ammonium hydroxide will be remaining, x moles of ammonium ions and x moles of OH minus ions will be there. That means 1 mole of ammonium hydroxide we are taking. In that, how much ammonium hydroxide remaining is there means 1 minus x moles of ammonium hydroxide remaining is there. How much ammonium ions means x moles, how much hydroxide ions means x moles. So how much ammonium hydroxide has gone for ionization, has gone for dissociation, x moles of ammonium hydroxide has gone for dissociation. So remaining ammonium hydroxide is in the form of undissociated form. So remaining in the sense 1 minus x moles of ammonium hydroxide is in the form of undissociated form, we can say. So ammonium hydroxide is a weak base, therefore it is not undergoing complete ionization, it undergoes partial ionization. So in order to make it to undergo complete ionization, what we have to do? We have to supply heat to make it to undergo complete ionization because it is weak base. So we have to force ammonium hydroxide to undergo complete ionization. How to force? By giving heat energy. So ammonium hydroxide takes heat energy and undergo complete ionization. Okay. So enthalpy of dissociation of ammonium hydroxide. Enthalpy of dissociation of ammonium hydroxide is how much in the sense plus 5.46 we can say, plus 5.86 kilojoule. Okay. So plus 5.86 kilojoule. This is enthalpy of dissociation of ammonium hydroxide. Okay. So enthalpy of dissociation of ammonium hydroxide means what? So 1 mole of ammonium hydroxide weak base undergo complete ionization, for which what is the amount of heat required, that is called enthalpy of dissociation of ammonium hydroxide. Okay, so weak base in the sense it will not undergo complete ionization, it will undergo complete ionization by absorbing heat. So we have to supply heat. So how much heat we are supplying? 5.86 kilojoule of heat we are supplying. This much amount of heat ammonium hydroxide takes for undergoing complete ionization. Okay, so ammonium hydroxide undergo complete ionization by taking heat from surrounding. How much heat it takes means 5.86 kilojoule of heat it takes for undergoing complete ionization. Okay, sir. So this ionization, this dissociation is endothermic, but this dissociation is not endothermic, it is taking place naturally. Okay, then this acid H plus ions, acid provided H plus ions and base provided OH minus ions combining to give what in the sense water. So H plus ions combining with OH minus ions to form water, while what is the amount of heat involved in the sense minus 57.32 kilojoule of heat is involved. Okay, so when 1 mole of H plus ions combine with 1 mole of OH minus ions to form 1 mole of water, while what is the amount of heat involved in the sense minus 57.32 kilojoule of heat is involved. Okay, sir. Now let us see what is the overall reaction. That overall reaction we'll see. Okay, now we can say this HCl aqueous we can write HCl aqueous. This ammonium hydroxide base aqueous we will write. This ammonium hydroxide NH4OH aqueous we have written. Then this H plus aqueous, this H plus aqueous cancels. This OH minus aqueous cancels. Then this ammonium ion and chloride ion we will write. This ammonium aqueous, then this Cl minus aqueous. Then we will write this water. Okay, this NH4 plus aqueous we have written. This Cl minus aqueous we have written. This water we have written. Now enthalpy of this reaction is equal to how much we will see. Okay, now you are mixing HCl and ammonium hydroxide. On mixing HCl and ammonium hydroxide, what is taking place? Okay, HCl naturally in the form of ions. Okay, ammonium hydroxide converting into ions by taking energy, this much energy it takes. H plus ions and OH minus ions combining to water, while this much energy is liberated. Okay, now see, in this when HCl is mixed with ammonium hydroxide, this much amount of heat is liberated, this much amount of heat is absorbed. Okay, both absorption and liberation both are taking place in this case. But in the previous case, strong acid versus strong base, only energy liberation. But in this case, energy liberation as well as energy absorption. Okay, energy liberation how much? 57.32. Energy absorption how much? 5.86. What is the net heat involved now? What is the net amount of heat involved? Net amount of heat involved is how much in the sense minus 51.46 kilojoule. Okay, so minus 51.46 kilojoule is the net amount of heat involved, we can say. Correct? So net amount of heat involved is minus 51.46. This is now net amount of heat involved. That means when 1 gram equivalent of HCl reacts with 1 gram equivalent of ammonium hydroxide to give salt and water, what is the net amount of heat involved in the sense minus 51.46 kilojoule. Therefore, it is called enthalpy of neutralization between HCl and ammonium hydroxide. Okay, so HCl and ammonium hydroxide enthalpy of neutralization is how much? Means minus 57.46. Let us compare this with a strong acid, strong base enthalpy of neutralization. Strong acid and strong base means enthalpy of neutralization is minus 57.32. But here, strong acid and weak base ammonium hydroxide means minus 51.46. Why amount of heat involved is less? Why enthalpy of neutralization? Why enthalpy of neutralization less here? Less in this case. In the weak base ammonium hydroxide case, enthalpy of neutralization is less when compared to strong acid and strong base. What is the reason? Because this weak base ammonium hydroxide consumes some amount of heat for complete ionization. That's why this magnitude is less. So enthalpy of neutralization here is less because this ammonium hydroxide is weak base which consumes some amount of heat. Okay, na? So strong acid and weak base means enthalpy of neutralization is less when compared to strong acid and strong base. Now what we will do in the sense, we will take a strong acid will take and some other weak base will take. What is the enthalpy of neutralization? We'll see how the enthalpy of neutralization value will be there. Do you feel? Shall we say enthalpy of neutralization between any strong acid and any weak base always remains same? Shall we say? Because we set one point in strong acid and strong base. What is the point we said? Enthalpy of neutralization between any strong acid and any strong base always remains same, we said. What about in this case? Enthalpy of neutralization between any strong acid and any weak base is always remains same, shall we say? No, we cannot say. Why we cannot say? Because different weak base require different amount of energy for complete ionization. Therefore, we cannot say. Okay, sir. Now we will say, we will take a weak acid versus strong base. We will take weak acid versus strong base. We are taking weak acid example is what? In the sense acetic acid. Let us dissolve this in water. Okay. Then we will take a strong base. Strong base example, we will take sodium hydroxide that will dissolve in water. On mixing both, we are getting salt. What is the salt? Means sodium acetate. Sodium acetate is the salt. Then we are getting water. For this process, what is the enthalpy of reaction? What is the amount of heat involved? What is the amount of heat involved is minus 55.2 kilojoule. Here amount of heat involved in this process is minus 55.2 kilojoule. Okay. Now, what is the enthalpy of neutralization for this process? That we'll see. Okay. Now, acetic acid, we have taken 1 mole as per stoichiometry. What is the N factor of acetic acid in the sense? What is the N factor, shall we say? How many hydrogens are there? Let us count first. Here 3, here 1. So, totally 4 hydrogens present in the acetic acid. Now, what is the N factor of acetic acid? Do you feel? Do you feel what is the N factor of acetic acid? Do you think? Sir, we'll see later. Now, sodium hydroxide, we'll see. Sodium hydroxide, we have taken 1 mole as per stoichiometry. This N factor is how much in the sense? This N factor is equal to 1. Sodium hydroxide N factor is equal to 1. Okay. Why? What is the N factor of sodium hydroxide? Sodium hydroxide N factor 1 we said. So N factor is 1 means number of moles is equal to number of gram equivalents. So sodium hydroxide N factor is a sodium hydroxide number of gram equivalents is 1 gram equivalent, we can say. Okay. Now, sorry. Now we can say number of moles of sodium hydroxide and number of gram equivalents of sodium hydroxide is same. Okay. What about acetic acid? We'll see acetic acid structure. We will see first. Okay. Acetic acid structure is what in the sense? This is CH3 C double bond O OH. It is acetic acid structure. Now, electronegativity of carbon is how much in the sense 2.5. Electronegativity of hydrogen is 2.1. What is the difference? Means the difference is 0.4. Difference is 0.4 in the sense this bond is not ionic bond. If the difference between two atoms is 1.7 or greater than 1.7, then only ionic bond we can say. Here difference is very less, therefore this bond is not ionic bond, therefore this group will not give H plus. This group will not give H plus, therefore this hydrogen is not acidic hydrogen. This hydrogen is not acidic hydrogen, similarly this and this. Okay, next we will see this group, OH group. This oxygen electronegativity is 3.5, hydrogen electronegativity is 2.1. What is the difference? Difference is how much in the sense 1.4. So here also difference is not greater than 1.7. Therefore, this bond also not a ionic bond. Okay. But the difference is a considerable value. Therefore, this bond is having polarity. That means what is a polarity in the sense oxygen is having partial negative charge, hydrogen is having partial positive charge. When it is dissolved in water, what happens means water pulls this H plus. What on pulling this H plus, this H plus comes out from acetic acid. This acetic acid, in this acetic acid, this OH group is able to give H plus in aqueous solution. Therefore, this is a acidic group. Therefore, this hydrogen is acidic hydrogen. So, this acetic acid is able to give one H plus. Therefore, its N factor is 1. Okay, so number of moles is 1, N factor also 1. Therefore, 1 gram equivalent we can say. So acetic acid, how much means 1 gram equivalent. Okay, so 1 gram equivalent of acetic acid reacting with 1 gram equivalent of sodium hydroxide, while this much amount of heat is liberated. Therefore, this is called what in the sense enthalpy of neutralization between acetic acid and sodium hydroxide. Okay, now here enthalpy of neutralization between acetic acid and sodium hydroxide we have given. Set. Now let us compare enthalpy of neutralization. This enthalpy of neutralization and this enthalpy of neutralization, let us compare. Here HCl is strong acid. Here sodium hydroxide is strong base. Okay. Here ammonium hydroxide is weak acid. Here acetic acid is weak acid. Here acetic acid is weak acid. Here ammonium hydroxide is weak base. That means in this neutralization, one is strong, another one is weak. Sir, in this neutralization also, one is weak, another one is strong. But why enthalpy of neutralization is different? Here you see 55.2. Here enthalpy of neutralization is minus 55.2. Here enthalpy of neutralization is minus 51.46. Here enthalpy of neutralization is minus 51.46 we can say. But here enthalpy of neutralization is minus 55.2. Why enthalpy of neutralization is different? But here we said in this case, this we discussed with this we compared with the strong acid and strong base. When compared to strong acid and strong base, it is having lower value. Why? Because ammonium hydroxide is weak base. In this case, if you see acetic acid is weak acid, here one is weak, one is strong. In the like that only previous case, no. Then why here enthalpy of neutralization is 55.2, but in this case 51.46? Why difference is there? Then shall we say this extent of weakness in ammonium hydroxide and the extent of weakness in acetic acid is a different or same? How it should be there? Because enthalpy of neutralization is a different, no? In a different manner it is there. What reason shall we say? Then this revealed that weakness of acetic acid and weakness of ammonium hydroxide is different. That's what it indicates. Correct or wrong? Weakness of ammonium hydroxide and weakness of acetic acid is different. That's why enthalpy of neutralization is different for these two cases. Isn't it, sir? So then we can say here acid is this acetic acid is a weak acid. Therefore, this enthalpy of neutralization is low when compared to strong acid and strong base. We can say, sir, okay. Now you are given the question. Here enthalpy of neutralization is less when compared to strong acid and strong base. Why is it so? Next question. This here weak acid is acetic acid. Since it is weak, it needs some amount of heat for undergoing complete ionization. What is the enthalpy of dissociation of acetic acid, you say? What is the enthalpy of dissociation of acetic acid, you say? Then what is the equations? How do you write equations for this in order to show like this? Okay, for strong acid and weak base, we have written equations like this and we have shown like this, isn't it? Like this, you write the equations for acetic acid and sodium hydroxide